Alright, so we're live. Okay, so hi everyone. So welcome back to our um, vlog. So today we will be having a special session wherein we will be discussing what a flowchart, what an algorithm is all about. No? So before we start, we'd like to give shout outs to all our friends who is currently watching right now and will be watching later on. Okay, so I decided to do this with concept of doing a iAsk session because since classes are suspended and since learning alternative learning sessions are also suspended, so it would be you know a good thing to do that sharing learnings here. So that's why I decided to do this learning session online right now. Okay, so before we start, once again, good evening to everyone. Okay, so let's see. So now you can see me. Okay, so let's start. So basically, this module is we will be focusing on the fundamentals of programming, wherein we will be discussing one of the most important topics whenever you will be doing programming, which is what we call algorithm. So basically, for this module, we will be discussing the different phases of the actually just an overview of the different program development lifecycle. And also we will be discussing the different characteristics of a good algorithm. Like how can you say that your algorithm is already okay, or is it already a good algorithm? So we will be discussing the different characteristics or criteria to determine if your algorithm is really a good algorithm. Also, we will be discussing uh, in this module the different flowchart symbols. Of course, we will be discussing the two ways of doing an algorithm, which is the pseudocode and the flowchart. So we will be focusing on the flowchart side. So we will be identifying different flowchart symbols and how can we use them accordingly and properly. And lastly, we will be creating a flowchart, sample flowchart, using one of the effective tools that I personally am using, which is no need for installation. You just need to create an account. It's actually a web based. Okay, so this will be our different module objectives for the ninth session. Okay, so again for this module, our target objective, actually general objective, will be we will be discussing the proper way of creating a simple flowchart. Okay, so I believe most of our viewers right now are actually computer programmers or computer programming students. So I believe that since you are creating program, sometimes it's a bit hard for us, no, to create programs because sometimes we are not guided on what to do first, what modules to do first, and making it very difficult and very um, time consuming, especially creating programs because we don't know where to start and we don't know where to end. That's why this module will be focusing on that direction, on guiding everybody on how to create a simple program with guidance of a flowchart. Okay, so let's start with the program development lifecycle. So whenever you create a program, you always look at these four steps. Actually, the program definition or problem definition rather. So basically, we need to define what is to be answered, what's to be solved in a specific program that you are going to create. So you need to identify the problem so that you know what solution will you be creating or providing. And that leads us to the second phase, which is the problem analysis. So for the problem analysis, you need to identify on the problem statement, you need to identify what is the input, actually even the process, and the output on the said problem. Like for instance, if you are required to create a program that will compute the general average of a student, so you need to identify what's the input, what's the expected output, and how you will be, or what processes, or what formula will you be using to derive the said output. Then next, it leads us to the next phase, which is the algorithm development. So here, we design the program. How do we solve the problem? So it's a step-by-step procedure on how to derive the output from the given inputs of the said problem. So for the algorithm, we will be focusing on the pseudocode and the flowchart. So for this module, we will be looking at the flowchart alone. Okay? So, and lastly, that would be the coding and debugging process. So here, the actual implementation of your program will be done and will be evaluated accordingly based on the problem that you have defined and based on the analysis that you have provided. So with the help of algorithms, basically, it will help you guide, or it serves as a guide for you to create a solution for a specific problem with accuracy. And the goal actually is to really lessen the time that you will be spending in developing a program. So with the algorithm, it will be easier, it will be faster, the program will be developed on time and within the specified period, no? Okay, so again, these are the four steps that or phases that involves in the program development lifecycle. So basically, you need to think about what's the problem and solution that you will be trying to imply or to apply to a given problem. So with the help of algorithm, you will be guided to do it, and you can code it and then later on debug accordingly. Okay, so again, for this module, we will be focusing on the algorithm side. So basically, when we talk about algorithm, these are the step-by-step problem-solving procedure. Basically, a step-by-step procedure. So it is established, recursive, computational procedure for solving a problem in a finite number of steps. The keyword here is actually a finite number of steps. The keywords, no? Finite number of steps. It means to say that the algorithm should terminate. No? Once it starts, it should always terminate. Sabi nga nila, walang forever, di ba? There's no forever in programming. Then next, an algorithm is a finite sequence of steps for solving a logical or mathematical problem. There's also a specific set of well-defined, simple mathematical and logical procedures that can be followed to solve a problem in a finite number of steps. So again, the goal here is um, to create a solution that has a start and must end. It also be clear enough and well defined and as simple as possible so that the programmer will be able to code it, and it will serve as a good guide for your programmers. So again, an algorithm is a step-by-step procedure. So basically, it's the way that you will solve a specific problem should be simplified and well defined. So how do you know if your algorithm is actually a good algorithm? So that leads us to the next slide. So in real life, algorithm, you can see algorithm examples in operations such as turning on your computer. Now, basically, when you turn on a computer, you need to follow a specific step. No? You need to follow it accordingly to avoid what we call uh, to avoid problems in your computer, like for instance short circuit, no? So you need to follow a series of steps. Same goes for the computation of the average. You need to identify what's the first, second, third, fourth grading grades of the student, and then add it, divide it, and then that's it. No? So, and then going to school actually is also actually provides you an algorithm as well. And enrolling in schools such as STI or washing your clothes. So you need to follow a series of steps. Otherwise, if you don't follow them, you will not arrive to the desired output that you want to achieve. So algorithms are basically just a procedure, step-by-step procedure that you need to follow to achieve a good result. Okay, so an algorithm can be good if it has this following characteristic. First, your algorithm must specify each step or instruction. So there must be no ambiguity and your instruction must be clear. So remember, when you create or define your steps, it must be specific. It must be clear enough for the programmer or the person who will follow or read your instructions. It must be clear to them on how each steps will be executed. So again, for the first characteristic, your algorithm must be specific. Okay? So for instance, it's like just giving an instruction. Like when your parents ask you to buy something, normally as a child, we normally just follow what their instructions, right? So if they tell you to go buy some soy sauce, just go to the store and tell the vendor like you want to buy this soy sauce, no? So then the vendor will ask you what specific soy sauce brand will you be buying. So you return home, then ask your parents. You go back to the store, and then again you'll be asked like how big, how small will you be buying for that specific soy sauce, and then you go back. So again, if your instructions are not clear enough, your results will not be easily will not be easily understood. So you need to be very specific on your instructions or your procedure. So that's one of the first criteria for determining if your algorithm is already a good algorithm. So the next one is that your algorithm must have a finite steps. Basically, it must terminate. Again, I already told you earlier that all solutions, all provided solutions or steps must terminate. It should stop. No? So for instance, um, uh, once you were asked to buy that soy sauce, a good algorithm must end. Meaning, there must be a satisfaction either from your side or from your parents' side on the given instruction. So your algorithm must have a finite number of steps. Uh, it must have an end and must actually stop. Which the stopping point is our goal or our desired outcome. Okay, and lastly, a good algorithm must have an output. So the algorithm must produce a correct result. Again, the word here is a correct result. So uh, it can be classified, it could be considered as a good algorithm if the desired result is actually correct and achieved. So for the case of the earlier the scenario that I've given earlier, which is to buy the soy sauce, actually is not a good algorithm because it actually delays the process. At the same time, eh, you know, maybe the kid, the one that has been asked to buy the soy sauce, was not able to um, buy it correctly or according to time, no? So uh, that's it. So again, these are the three uh, criteria, or these are the three things that you need to consider when writing or doing your algorithm. So as programmers, basically, once you create your program, you need to follow the three uh, criteria as well. So you need to have a Instructions or your programming codes must be clear enough so that others can easily understand it, knows how to rearrange it and improve it. Your program must have an ending point. No? It should end at some time. And lastly, your program must produce an output. So that's the three things that you need to consider in writing your good algorithm. Okay? So an algorithm can either be a pseudocode or a flowchart. So what differs the two? So when we talk about pseudocode, basically a pseudocode is just a generic way of describing an algorithm. It means to say that you are writing uh, your step-by-step solution in a specific programming syntax. So for instance, if you're a Java programmer, you need to follow Java programming language syntax to write your pseudocode. So it is a code, or it is a set of instruction that is closer to the actual code that you will be using. No? So it's actually a guide for programmers. So it cannot be executed on a real computer, but it resembles. No? It's closer to the programming code, real programming code that you are intending to apply it on. So that's the pseudocode. Okay. So on the other hand, when this is an example, by the way, of a pseudocode. For instance, if you are going to wash your clothes, you need to follow these steps. So if you observe the wordings, the highlighted keywords here are the keywords that you will be using when you will be doing the code. So for instance, first you need to get all the clothes in the basket. So while the basket is not empty, you need to compare the color of your clothes. So if the color is equal to the dominant white, meaning it's white, so you need to segregate them and place them in one container with bleach. Otherwise, else, place it on the washing machine and repeat the entire process. So that's how a pseudocode looks like. Okay. So when we talk about flowchart, this is a graphical representation of the solution that you have proposed. So it's a chart that contains symbol referring to computer operations, describing how the program performs. It is also a graphic map of the path of control of data through the operations in a program or information handling of a system. So basically, this is just a graphical representation of the solutions you intend to produce. So since most of the programmers are visually uh, are more on the visual side, so we normally use the flowchart to create our own solution or algorithm. Okay, so these symbols are such as the squares, diamonds, and ovals, which represent the different operations, which later you will be able to see. No? So these symbols are connected in lines and arrows to indicate the flow of the data or control from one point to the other. So you will be seeing some lines, some flow lines in your flow chart. Okay, so these are some of the flowchart symbols that you can use. Actually, these are just some, no, some. There are still other flowchart symbols that you can use, no, like for instance, databases, which has a different symbol. So these are just the typical or commonly used flowchart symbols. Okay, so first we have the oval. So the oval is actually used for the terminal, so the start and the end of your what do you call this one, flowchart. We also have the process block, which contains the process action that needs to be performed, so it's represented by a rectangle. We also have a parallelogram, which is for the input and output block. We also have the arrow lines, which we call as flow lines, decision block, which is a diamond, so this is used for decision making, initialization block, which is a hexagon, right? On-page connector is represented as a circle, and an inverted pentagon for the off-page connector. So let's look at them one by one. Okay, so flow lines is indicated by a straight line with an arrow to show the direction of data flow. Okay, so the arrowhead is always shown even when the direction of flow is clear. So we still need to uh, uh, emphasize the flow line with an arrowhead to show the direction, no, of our flow, or the process that we're going to provide or create, and then use to connect blocks by existing from one and entering from another one. So if you observe, so here in our diagram, so this is the proper way of using the flow line. Okay, so it must have a arrowhead. No, so if you don't have the arrowhead, this will be considered as incorrect. Okay, so here, if you observe, a line should be connected to another line, no? If you observe here, so it's improper to connect the lines to the block itself because there are rules actually for the different blocks. So later on you'll get to know why this one here is incorrect. So but again, the point here is that if you wish to go back to a specific process, you didn't need to create it to a rectangle shape, but you need to create or connect it to another flow line. So this rule here applies to the process block, which is later you'll know what are the rules in using the process block. Okay, so yeah, so again, this is the flow line. So it basically tells us the direction of the data flow. Okay, so it should have an arrowhead. Okay, so to indicate the flow. Okay, so next we have the terminal block. So for the terminal block, it is represented by an oval or rounded rectangles. No? So this indicates the start and the end of our module. So as you observe in the figure, it is labeled the start and end. Okay, so aside from that, you could also use the end or stop or start for the label. Okay, so a start has no flow lines entering it. So for the start, no lines should be coming in for your flow chart. Also, for the end, it has only uh, one one flow line coming in or entering it, but no exit lines will be provided. So if you observe in our figure here, it is incorrect because for a flow chart, there should only be one starting point and one ending point. So avoid having multiple starting points or endpoints in your flowchart. Actually, that's incorrect. Okay. So again, for the start terminal, uh, only one exit line will be used, and for the end, only one uh, entry or entering line. No? So no more exit lines. Okay, so that's for the terminal block. Okay, so next is the initialization block. So basically here, the initialization block. I'm sorry, is used for declaring or initiating variables. So when we talk about declaration, basically we are just stating a variable. So what are the variables to be used? So for instance, if you could see in this diagram, it only tells us that x and y are just integers. Okay, so that's a declaration block. So for the initialization block, this one here, it tells us that this is to set or prepare or to format a specific variable. So allocating initial values to these variables are what we call the process of initialization. So that's again the initialization block. So it is represented by a hexagon, right? So hexagon. So next, we also have a process block. So the process block is represented by a rectangle shape, and then here you indicate in the process block the calculations that you'll be using in a specific uh, process or a specific flowchart. Okay, so for the same for the similar with the initialization block, the process block only has one entrance and one exit. So one entrance and one exit. So this is what we showed you earlier, that for this example, this is incorrect because this is a process block and it has three output lines, which actually defeats the definition of the one entry and output lines. So that makes it incorrect. Okay, so again, for the process block, we will be using a rectangular shape, and we actually specify in the process block the different process or activities that you will be doing in a specific solution. Okay, we also have the input output block. So this is represented by a parallelogram. So it has also one entrance and one exit lines. So this is used for like for instance of displaying or uh, getting or entering user inputs to your program. Okay. So next is the diamond. So for um, the diamond block actually is used for decision making. Okay, so it is a decision block. So it has one entrance, but this time it has two exits, only two exit lines or flow lines, getting out of the diamond or decision block. So if you observe here in our diagram, we have either true or false. So if the action is true, we proceed to the left side, and while the action is false, we proceed to the right side. So it has only one entrance and two exits, and these exits can either be true or false. Okay, so if you're using the if statement in the condition, so you need to use the true or false. Otherwise, if you use um, the is statement, you need to use the yes or no. Okay, so yeah. So next, we also have the connector. So for the on page connector, it is used. You will use the circle diagram or shape to indicate an on page. It means to say that the continuation of your flow chart is within the page. Okay, so it has one entry point for the first part and one exit point on the other part. Okay, so as much as possible, you need to minimize the use of connectors in your flowchart as much as possible. Okay, so for the inverted pentagon, this is used for the off page. No? So it means to say that you will be using uh, the or the continuation of your flowchart is on the other page. Okay, so that's it. So for example, uh, let's take a look, for example, at this problem. Okay. Okay, so basically in our sample problem, we have you need to create a program that displays the your age 5 years from now. The algorithm should have a variable that is initialized to your current age. So how do you think the flowchart would look like? So if you read again, when you identify the problem, you need to understand the problem and then analyze it. So for this problem, it has the keyword of display. So thus, it has the output of 5 years from now. Okay. So you have the keyword initialize is also provided, which means you'll be needing an initialization block. So in this problem, basically your age is given, so you need just to display your age 5 years from now. So the solution would look like this. Okay. So we start again. We start and we also end. No, or stop. So for the start, it is preceded with an initialization block. So we declared a variable age, and we assumed that it was or it is 18, no, 18, we're 18 years old. So and then after which, after assuming the age, we proceed to the process, which is to calculate the age 5 years from now. Then right after the calculation, you use the process block for this calculation, and then lastly, you need to display the output. Okay, so again, how do you know if this is a good algorithm? So first, let's check. So is it specific? All right, so it's specific. So age is basically um, written there, so it's very clear, no ambiguity. And then is it does it have a finite step? Yeah. So it has a few steps, no? And then it has a start and end. And lastly, does the problem or your algorithm has a output? So basically, if you see there is an output, so it is represented here. So by just displaying your um, output. Okay, so that's actually how basic flow charting is done. So actually, the tip here is that you need to just know the different rules in writing a flowchart for you to be able to create one. Okay, so since we're already done with our first part, so let's look at now uh, the software that we will be using for translating these figures or our flowchart into a printable one. Okay, so actually you can use Word. The Word is okay, but the problem with Word is that not all symbols are available. At the same time, it's actually hard to create your flowchart in Word because Word is just this software is dedicated to creating documents, but not flowcharts. So today, I'll be introducing you to what we call uh, the Lucid Chart. Okay, so you can just go to this website. Okay, so just type in um, lucidchart.com. So it will uh, redirect you to this site. Okay, so this is the site. So if you do not have an account, you can sign up. Okay, but if you do not have an account, rather if you have an account, you can log in, and if you don't have an account, you can create your own account. So for instance, assuming you have already have your account, so we will be clicking to log in. Okay, so if you don't have an account, you can just create one. So I'll be using my Office 365 to log in. Okay, yeah. So actually this Lucid chart allows you to create 3 documents for your use, no? So you can see here, this is their like homepage, no, for users. And if you can see, there's a new document here. These are the documents that I have created. Okay, so for now I have one. So for this demonstration purposes, we will be creating a new one. Okay, all right. So okay, so sorry for that. So now we have the different documents that you can create on the Lucid chart. So since we are in the concept of flowcharts, so click on the flowchart. So here you can choose, but you can choose other or templates, but we will be using the blank one. Okay, so just open template and then it will reloads. It will open a new page or a new tab, and then with the blank document. Okay, so this is the one that we were, and then once we click the blank, it will open a new window, so or a new tab rather. So a tutorial
Making
will
a dot.
be presented, so you can opt to click. Got it. Okay, so you can zoom in, zoom out actually the page. Okay, so zoom in, zoom out. Okay, so let's take for example let's take for example this one. Okay, so you need to create a program that will determine if the user is eligible to vote, assuming the user is 25 years old. So again, let's analyze this problem. So the problem basically asks us to determine if. So the word if means that we will be using a decision block if it is eligible to vote or not. Okay, so the age is 25 years old. Okay, so that's the assumption for our problem. So, okay, so going back to Lucid Chart, so we have our Lucid Chart here. So again, we need to start. Okay, so just drag, actually just from the toolbox here, the side shapes, just need to drag. Okay, drag it over to your blank document. Okay, so we can zoom it in. So by default, it has a terminator. So this just double click it and then you start typing. So let us say it start. Okay. So for our problem, accordingly, you need to create a program that will determine. So the first one here is there is an assumption of the age. So for instance, it's for the given problem, it is the age of 25. So going back to our Lucid chart, so the next object that we will be creating is guess what? Right. So we need to create an initialization block. So the initialization block is represented by a uh, hexagon. So again, same process. So just drag it over to your document and then double click. So again, we will be declaring it as an integer and the age is equals to 25. Okay. So what's good with Lucid Chart is that it allows you to create directly the lines by just dragging or clicking on the different four plus signs. So for example, I need to connect the start to the int age, so I need to click this one, okay, and then automatically it connects to the next object, which is here. Okay, so it's what's good about this is that it can be easily done, you know, with our document. Okay, so right after the assumption is we need to decide whether this age is eligible to vote, right? So we will be creating or using a diamond because we will be deciding. Okay, so we will have a decision. So I will be using this statement. Okay, so again, double click, and then if or is the age, how do you know if eligible, if the person is already eligible, is that if the age is already 18 and above, right? So greater than or equals to 18. Okay, so is it so if yes, we will display. So we will drag a display uh, symbol here. So if the age is greater than 18, so we will need to display user is eligible to vote. Okay, otherwise we need to display that the user is not eligible to vote. Okay, So again, connect this to this object, our initialization object, to the next object, which is our decision block. And from the decision block, so the first block you need to connect is actually the true statement. Okay, so from here you connect it there, so it would be the yes. But if you start it here, it would still be the yes. So since our logic tells us that this is the true statement, so we need to connect it to this block. Okay, so and then the no block should be connected here. All right, so since we're already done, so we will be inserting a new terminal block, and we will call it as the end. Okay, so display, we need to connect it here. So one more tip. So some of us forgets to terminate our processes. Like for example, this one, we forget to terminate this one, right? So sometimes as a human being, we tend to forget that, like, if the statement is yes, we don't know where to proceed. So since this is a flowchart, it needs to have an ending, right? So it needs to end. So if that statement is true, uh, we will display the user. Right after displaying the user, what will we do next? So basically, we will also end this process here. So we need to connect it to the end. But again, it's not like this. It's improper to do this. So we will just do it and connect it right here. Okay, so this is the more proper way of doing it. Okay, so right, like that. Okay, so that's how simple Lucid Chart is. Okay, so I guess that ends our basic session here. So if you have comments for our basic flowchart, you can leave your questions or comments on the comment section below. So don't forget also to uh, like and subscribe and click the notification bell to get to know more inputs or about get to know more about this channel. Okay, so thank you very much and see you next time.